This is for college algebra 4.2, how we graph rational functions. Graphing a rational function is a lot of work. Actually, there are 9 steps for you to do in a rational functions. So this is where you have to follow all these 9 steps in order for you to graph the rational functions. So it actually is the 1 page to 2 pages long to do it. And a lot of students struggle with this. So there are the 9 steps here. So the first thing we're going to talk about here is if you have a rational function, which is numerator over denominator, n and x, n is numerator, d is denominator, and it makes sure that your denominator is not the zero of a polynomial. The meaning of a not a zero polynomial here means that you cannot have a zero denominator because of that means that you cannot have a zero in your denominator because it will be undefined for that case. So how do we do first is first you have to simplify this function first by factoring, and if you see any common factors that you have to cancel the common factors, and then you have to list the restriction of the domain. So actually you have to find the domain of the function of this rational function. Usually the domain is all real numbers except for those will make your denominator become 0. And once you figure out, once you finish the step 1, step 2 is where you start to do find your y-intercept and you have to plot it. So how do you find your y-intercept is plugging your x to become 0, or another meaning is find f of 0. So put x, all your x becomes 0. That's how you find your y-intercept. Third way is to find your zeros. Your zeros is also called your x-intercept. So in order for us to find the 0 or the x-intercept, you solve the nx. Nx is your numerator equals to 0. So you just put your nx equals to 0 and you solve for x. And that x value is what we call as your numerator. And then the next thing is we have to figure out if there is a whole exists in your rational functions. How do we figure out if there's a whole exists is when you factor it out, and if you cancel any common factors, these common factors that you cancel is what we call as wholes. And in order for you to find this, you have to make that common factors that you cancel equals to 0. And let's say this is x plus 3 and you got x plus 3, you got cancel them out. You have to make them equal to 0. So x plus 3 equals to 0. X is negative 3. That is where the whole exists. But this is just for the x. Now you have to substitute the negative 3 into the f of x, and you have to find the y value. So in this case, the whole is a coordinate. In this case, it will be negative 3 for x, and for y, you plug it into the negative 3 here, and try to figure out what is your y value, and that is a coordinates of the whole in this case. This is only what happens when your common factors has been cancelled. If you don't have any common factors that is cancelled, that means the whole will not exist here. Next, you have to find the vertical asymptotes. So in order for us to find the vertical asymptotes, your denominators has to be equal to 0. It's the same thing as finding, make your denominator equal to 0 and solve for x. This is how you find your vertical asymptotes. This is step 5. Step 6, you have to find either a horizontal or a slant. Sometimes we call it oblique asymptote. So in order for us to find the horizontal asymptote, you have to look at your n and m. Don't forget, n is the power of the numerator and m is the power of denominator. So if n is less than m, so the power of numerator is less than your power of denominator, then you have a horizontal asymptote of y equals to 0. Means that your horizontal asymptote will be on your x-axis. If both of these power is the same power, then the line, the y equals to an over bn, which is a ratio of the leading coefficients, will be your horizontal asymptote. What happens if n is greater than m? So if n is greater than m in this case, so it will what we call as a slant asymptote. A slant asymptote or oblique asymptote in this case is an asymptote that can be a straight line, which looks like y equals mx plus b. It can be a parabola, y equals to ax squared plus bx plus c, or it can be a cubic function, or it can be any other functions that you learn in chapter 2 and chapter 3. However, in this class, we will be just concentrating on y equals mx plus b, which is a straight line. So in this case, usually that your numerator is exactly 1 more than the degree of a denominator in order for us to have that. And in order for you to find the Slant asymptote that is in a linear, we call it the linear form, y equals mx plus c form, you have to use syntactic division. Now, the reason why we did not learn the Slant asymptote that is in the quadratic or cubic form is because one, your Slant asymptote can be only found not using syntactic, you have to use long division. And two, graphing this will be very difficult if you have a parabola or a cubic type Slant asymptote. So that's the reason why that in this class we will just only concentrate on the one that is straight line. So I just want to put it down here. In our class, we will just do y equals to mx plus b line. And how do we find this? You use syntactic division. Step 6. So that means that you can only have horizontal or you can have Slant asymptote. You cannot have both of these asymptote. Just want to point out to you guys. And then number 7 says that you have to substitute your horizontal or Slant asymptote to f to solve for x. So what it means that, let's say you find that your horizontal asymptote is y equals to 3, then you have to substitute your f of x equals to 3, so that the reason why you have, and then you try to solve for x, the reason why you're doing this so that we want to figure out if the graph will crosses your horizontal or Slant asymptote. So this is how we figure out, sometimes when you do the graph, your graph can cross on your horizontal or your Slant asymptote. And how do we do this is we set the function equals to whatever you found in question 6, either the horizontal asymptote, and solve for x. If you cannot solve for x, that means that this graph will not going to cross on these asymptotes. And just again, to remind you guys, your graph will never cross on the vertical asymptote. So if I see any graph that is crosses on the vertical asymptote, that goes up and down, you will not get a good points in this case. This is step 7. Step 8, we do the behavior of f on the vertical asymptote if the behavior goes to, if your f of x goes to infinity or f of x goes to negative infinity. This is what I just explained to you guys on video 4. On the previous video, which is 4.1 question 1 about the behavior of the f. So if you haven't watched this video, please go and watch it from the previous video. How do we figure out this behavior? And finally, make sure that you graph it. When you graph it, you have to graph everything. You have to graph your x-intercept, y-intercept, your whole, if you have any, vertical, horizontal, Slant asymptotes, and then you have to figure out your behavior and figure out if they crosses on your asymptotes, your horizontal Slant asymptotes. And when you draw the graph, make sure that the graph is a smooth curve. So that means that you cannot draw a graph that is zigzaggy or W shape like this. So make sure the graph is smooth. And so this is how the 9 steps of graphing this rational function here.